Hey, hello everyone. It is 11:25 p.m. Friday, June 13th. It is in fact Friday the 13th, which is a scary day, supposedly. I don't know. Today was pretty fine. I got my code working today at work, so that was nice. I spent like the whole week just trying to get it ready to be pushed. I'm new to the system because I'm an intern over the summer, and I wasn't exactly piecing everything together. It was taking me a bit to figure it all out, but felt good getting it prepared for today. That felt good. Today we're gonna work on a couple of mediums on binary search. Hold on, I need to put on some thicker clothes from over my shirt because it is cold in my room. I'll be right back. Okay, I'm back. So, here we go. I don't know, I saw these, so let's get into it. So this is supposed to be binary search. So Coco loves to eat bananas. They are in piles of bananas, and on the ith pile, the ith pile has piles of bananas. Coco can decide her banana. Coco can decide her bananas per hour eating speed of K. Each hour she chooses some pile of bananas. Each hour she chooses some pile of bananas and eats K bananas from the pile. While the pile has less than K bananas, she eats all. If the pile, dude, I'm so like bad at reading. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly, but still wants to finish eating all bananas before the guards return. Return the minimum integer so that such that she can eat all bananas within 8 hours. Okay. It's binary search, so like typically has to be on something sorted. So n log n. Interesting. I feel like all the time I think these mediums, I mean, from all the stuff I've done, these mediums have been like 30,000 times harder than the hards. The hards I'm able to like do on my own. These mediums, it's always some like obscure thing. It's like, well, if you know this, you can do it. It's like, well, that's not really a medium. These are like an introductional kind of like basic for the algorithm. Medium is like some advanced kind of way of thinking about the algorithm that requires outside thinking, and then a hard is literally just kind of like a more difficult version of an easy, in my opinion. I think mediums are like the hardest out of everything I've done. I feel like I've been having the most challenge with mediums because like this problem, like I'm stumped. You know, like I don't even know how to mathematically break this one down. Oh, I'm so tired. So your number is going to be determined by the number of hours. So hour has to be bigger than n, right? It doesn't directly say this, but I'm assuming hour has to be bigger than n. an hour is equal to n, then the piles has to be equal to the max. I use hints. I'm not gonna sit here forever trying to figure this out. Okay, so the upper bound would be the max. Upper bound for K is the max. Yeah. Why? Because Coco, yeah. Which makes sense. So do you apply the lower bound here? Consider M to be the largest pile and N to be the number of piles. A brute force solution would be to linearly check over the values from 1 to N and find all minimum possible values at which Coco can complete the task. This approach would be O of N times M. Dude, what? I'm missing like how exactly this makes. Like I'm missing. I bet this will make sense like when you visualize it. But like, what is the linear pass? Okay, would consider an N to be a brute force solution would be to linearly check all the values from 1 to N. Okay, but to what am I checking it, brother? To what? I mean, I don't get it because it's like. Yeah, no, I don't get it. I'm watching a video.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve Coco eating bananas. But before we do, I just want to say that if you do have any requested problems, you can feel free to leave those in the comments. I do have a large backlog of requested problems that I'm working through, so it may take some time for me to get there, but you can feel free to request at any time. And if you find this video helpful, don't forget to leave a like and subscribe for more videos. So this is a pretty interesting problem because there is a brute force solution that we can arrive at, and that brute force solution can easily be transitioned into a binary search solution, which is the optimal solution for this problem. So we're going to be working our way from the brute force to that binary search solution. So Coco loves eating bananas, and we have n piles of bananas. Already we're given some key information. Let's say we're given a certain number of piles, right? So basically the length of P, H must be greater than or equal to the length of P. Why is that? Because let's say we have 5 piles, right? So tell us in the problem is we want to determine that eating speed K that Coco is going to eat at, but we want to know the minimum integer K, the minimum eating speed of Coco that she could eat all of the piles in exactly 5 hours. or exactly whatever that time interval, that number of hours happens to be. So let's take a look at this example. They give us an input array of 4 piles, and they give us 8 hours to eat all 4 of those piles. What's the minimum K, the minimum eating speed that Coco could use to eat all of these piles in at most 8 hours? So we have to eat all the piles in 8 hours or less. Well, the brute force would be to start at 1, right? Because Coco could try K equals 1, right? Can we eat all piles in 8 hours then? Well, it will take us 3 hours to eat the first pile, right? 3 divided by 1, which is our K, right? 3 divided by 1 is going to be 3 hours to eat this first pile. And to eat the second pile is going to be even more. That's going to be 6 hours, right? 6 divided by 1, 6 hours. So far we already have 9.
Okay, wait, I understand it now. So basically at each log of in time, I do a check. Okay, so hold on. He did mention that in hint 2. Oh, dude, you gotta be smarter, Sterling. I'm wondering if this works in Python. I've never done this in Python before, so I don't know if this is Oh, yo, peak. This does work. Yeah, let's go. Dude, I gotta remember my binary search, man. Like, I know binary search, but I gotta remember like the exact syntax. I feel like it's so... You know? Yeah, hold up. Let me open up my, No. Sorry, let me open up my binary search. Wait, no, hold on, I don't get it. Huh. I gotta think for a code. I'm not gonna lie, he's gonna have to explain more. Hold up. He's gonna have to cook a little bit more.
Hey everyone. the values aren't too important, right? 1, 1, 2, 2, 3. And let's say we had h equals 4 hours. Well, let's say k equals some really big number, like 3, right? Basically the max of this input array. Okay, Coco ate this entire pile, Coco ate this entire pile, this entire pile, and this entire pile, because she could only eat 4 piles because we only have 4 hours, right? Coco can only eat 1 pile per hour. So if she ate all 4 piles over here, we'd still have 1 left over. That's why they guarantee us that h is always going to be greater than or equal to the number of piles. So the minimum in this problem, given this input array, h, the minimum it could possibly be is going to be 5. And I sort of wrote over it, but the last important thing that they tell us in the problem is we want to determine that eating speed k that Coco is going to eat at, but we want to know the minimum integer k, the minimum eating speed of Coco, that she could eat all of the piles in exactly 5 hours, or exactly whatever that time interval, that number of hours happens to be. So let's take a look at this example. They give us an input array of 4 piles, and they give us 8 hours to eat all 4 of those piles. What's the minimum k, the minimum eating speed, that 6 hours? So far we already have 9 hours, and we haven't even eaten the entire number of piles. K equals 1, right? Can we eat all piles in 8 hours then? Well, it will take us 3 hours to eat the first pile, right? 3 divided by 1, which is our k, right? 3 divided by 1 is going to be 3 hours to eat this first pile. And to eat the second pile is going to be even more. That's going to be 6 hours, right? 6 divided by 1, 6 hours. So far we already have 9 hours, and we haven't even eaten the entire number of piles. So therefore, k equals 1 is not going to work. And we could just continue this brute force approach, right? Now try k equals 2, right? And then do the exact same computation with k equals 2. Now my question to you is, we know that the minimum possible solution would be k equals 1, right? K can't be 0 because that would mean we're not eating any pile. So the minimum is 1. What's the max?
Wait, okay, I think I do understand. Dude, this is tricky. I had a feeling it's a little wrong. That doesn't look right. Ah, okay, beautiful. The number of hours would be the number of bananas, and then bananas per hour. Type. So if ours is greater than H, it means we're eating too little bananas per hour, right? It's taking too many hours to eat all the bananas. I need more bananas. So I'm going to say that minimum value equals bananas per hour plus 1. Else? I mean, I'm wondering if we should do an equal clause. I'm thinking maybe not. That's kind of word vomit. Oh well. That's just the way it goes. Dude, learn to spell, for Christ's sake. Ah! Oh my days. No! Oh my god. Please, brother. Lock in, bro. Lock in. Oh my god. Hey. Nice. Okay. Yeah, that made sense once you kind of break it down a little bit. But I needed a lot of those hints to understand that. But nice. Thank you, Mr. Neat. Appreciate that, big dog. Coco is done eating bananas. No more bananas for Coco. I need to find the minimum in a rotated sorted array. So, suppose an array of length n, sorted in ascending order, is rotated between 1 and n times. For example, 0, 1, 2, 3, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, and 2. If it was rotated 4 times, if it was rotated 7 times, it would be the same. Okay. Notice that rotating an array 1 time results in, yeah. Makes sense. I mean, this reminds me of mountain sort, or yeah, that's a mountain order. Is that what they call it? I forgot how you. Dude, I did a leak code on that one a long time ago. It was a year ago now, over a year ago. Wow. Sure how time flies. Where I did a leak code problem on mountain sort. That one was fun. Now here I am Trying to think about how to do Lee Corp on this one. Okay, so my idea is, I guess, similar to how like maybe a GPU would find contrast. I could be wrong, but it's like I'm on one side, it's big. I move to the other side, it's small. You know? I feel like you won't be able to find out until you move. Like, what if you land on it? See, that's the trick. There will be a point in the array where there's a small deflection from the increasing sequence. Right. Or not. You can divide the search space into two. Oh, this is telling me to use binary search. So, yeah, I'm looking for the inflection point pretty much. I'm going to treat this as a circle, I'm guessing. I'm wondering if one way you can do this is by landing on it, checking the value to the left and the value to the right. Now, if it follows proper principles, the value to the left should be less. It should be less, the value to the right should be more. But if it gets to a point where both values on either side are greater, then that is the minimum. That is the inflection point. So, here is how I am going to do that. I'm going to say left pointer is going to be equal to 0. Right pointer is going to be equal to length of nums minus 1. Right? And then basically I'm going to say, while left pointer is less than or equal to right pointer, I'm going to say middle point is equal to left pointer plus right pointer minus left pointer mod 2. Or not mod 2, division 2. Okay, and then I'm going to do my check. I'm going to say this is the tricky part, you know? Because, like, okay, how do you know if you should move left or right? Like, how do I know that the right side is where I don't want to be? You know? Calling on both sides would make more sense to me, but that still just kind of defeats the purpose. That's not log n. If I do a thing on both sides, it will then basically get to approximately n by that sorting. The beauty of binary search is I'm literally cutting off half. So I have to figure out if I'm at 5 and I check 4 is less than 5, and 1 is less than 5. Well, I can kind of tell from here, oh hey, something's up, but even still, that one is pretty simple because that one I just know to go to the left. Like this one, okay. How do I know where to go? How do I know what is true and what is not true? Right? How do I know? I don't know. Can I do binary search to find this cut? I mean, I'm assuming yes, but I'm just like confused because like, what am I cutting out? At least 2 of L mid will always be in the same sorted segment. Huh. Okay, that's smart. We're using more variables to test. That's pretty smart. So if I'm on like the left, right, middle, okay. Left is less than middle is less than right. Then I know it's a standard binary search, and then I just need to keep moving. Right? Well, actually, no. If it's that, then I know that left has to be the smallest. There's no other option. In that case, which is interesting. I think so. If hold on, let me 120 201. Okay. So, if left is less than middle and less than right, then it has to be left. Okay? And then I'm guessing it's the same difference if left is less. Sorry. Wait, huh? If left is greater, oh, here you go. If left is greater than middle, and middle is less than right, well, then we know that the answer has to be, well, we actually don't know. Because this is too simplified. Shit. Sorry. Less is left, less than middle. Ah. So this is the proper order. So that means this side we cut out. This side we cut out. Focus on this side. This one we focus on this side. We focus on the improper order. Is that true? 0, 1, 2, 3, 4, 5, 6. Oh my gosh. Come on, dude. Relax. I hear you, man, but you gotta chill out, dude. I got hair care product, man. Can't have my hair care product near you. Cat is jumping on my chair and tweaking out right now. I was literally just giving him like some cuddles a second ago, and he's not having it right now. He's demanding more. He's starting a union. He's unionizing for some more cuddles. Yes, I feel you, buddy. I'm right here for you. Yep. Thank you, Max. You gotta be careful, brother. Okay. I don't want to get any stuff on you, man. Stop it! Stop it! Oh my gosh. Max, please. Please, Max, please, relax. Just sit down. Just sit down. Relax. Cats. You love them, but man, do they want to get all up in the way. So we have left, right, and middle. Oh, you know what? I was doing 3 different versions, but one of these versions won't. No. These all could work, right? So like, let's see how I would work this one out. Okay. I have left, middle, right. So I'm gonna yoink all of these. I'm gonna put them over here. Okay, in this instance I have left is less than middle, and middle is greater than right. So that I know the inflection point must be on this side. Because that means things on the left are getting smaller, while things on the right should be smaller than the left. So the inflection point should be on the right. So then what I'm going to do is I'm going to, let me go here and I'm going to put in 3, 5, 2. Left, middle, right. Okay, so left, have my middle, on my right. My left is less than my middle, like that. So I know left has to have the answer here. So that's how you do a situation like that. But what if I got a situation like this? No, Max, relax. Come on, buddy. Lock in. 5, 0, 1, 2, 3, 4. Left, middle, right. Okay. So I have left, I have middle, I have right. My left is greater than my middle. My middle is less than my right. So this is the odd out. This is the oddity. So I know I must check over here. I know I must check the left side because the left side's the odd one. I'm gonna write this in red. 5, 1, 4. Well, I think which one gets qualified as the middle here? I don't know, but this is middle. Or it'd probably be this one as middle. Alright. Come on, buddy. Relax. Max, relax. Stop, Max. Please. So, I have... let's see. I have my left is equal to my middle. And my middle is... So this is kind of like a wild card, so this could be either or in this situation. This would only happen if it gets to the final draw. And middle is going to be less than right. So, oh, I'm lying. Middle is greater than right. What's up, buddy? Hurry. Dance. Macho man. I wanna be a macho man. I would then move it once more to have it would be basically like LM like that. So if I look at the inflection, I would treat this as either or. So I would treat this kind of like this situation, which means I go the oddity, which means I move right. This is a very interesting problem. See if I can program this right now that I kind of decently understand it on a molecular level a bit. Probably not. Probably won't be able to program it. I'm Swiss cheesed right now. Oh, hello, hi, how are you? We go with the side of the oddity. Middle should not be greater, so side of the oddity. This means left pointer is going to equal to middle pointer plus 1. LF. Again, I don't have to do LF on this one, but you know, I like it. Oh, hello, buddy. I know. He's laying on my lap purring right now. Theoretically speaking, I should have hit a value, but I don't know for sure. So we'll see. Hey! Well, that's because I spelled it wrong. Surprisingly, didn't run into that problem on the test cases. Wrong answer. No! No! Okay. What happened here? Let's look at this. Let's break it down. See if we can understand where I messed up on this. So, first we start off rip, kind of got everything lined up. Left is 3, middle is 1, 2 is, right is 2. Is 3 less than or equal to 1? No, it's not. Hi, buddy. Hi, baby. Yes, I understand. Okay. All right. Alright, need to understand what's going on in this problem. Oh, we're missing a space here. Three, 1, 2, 3, 3, 3. How the hell did that happen? Maybe we don't do the minus and plus. I think the minus and plus is bad. Although, wait, you know what is interesting? I'm curious to see if this has any value. No, it does not. Okay. That's okay. I was wondering. I was thinking it probably would not, but I was, we are hopeful individuals. I feel like it's gonna give me an infinite loop per chance, right? Yup. Ow, that's problematic. A stupid potential solution. Actually, I do want to see. I do want to see this again. Or wait. In this instance, it's not M. It's right. Ja? No, it isn't. Wait. Oh, this doesn't matter. This is still an in-betweener. Did all this because I wasn't paying attention. I mean, where both sides are greater, like, we've seen that. I guess our solution is like, hey, check if this middle point is a inflection point. Else, bleh. Just so, yeah, I don't like that. So, we're gonna do a check. We're gonna do a check. I'm gonna basically say if M is less than nums of middle pointer nope. You okay, buddy? Oh, hi. Hi. Yes, hello, good sir. How are you, good sir? Gotta make sure I keep it in my window. You know? What? What are you sniffing? What are you sniffing, huh? What are you sniffing? Oh, such an angry gentleman. Such an angry gentleman. Where is your cordialness? Where is your cordialness? Oh, hi, buddy. Yes, you're so cute. I'm basically I'm just gonna loop around. So like, I'm gonna do +1, and if the value +1 is greater than our window, so like if it's farther than the right pointer, then it needs to be looped back around in a cyclic manner. So it needs to go back to the left pointer. And then I'm doing the same thing here. This is basically just asserting the things. Oh, bye-bye, buddy. Cat got tired of me. He's moving on. It hurts. This is silly, but let's see. I mean, I hope it works, but being silly doesn't always mean getting the answer. And it worked. Voila. See, I'm kind of curious what the actual, nice looking solution is. See, look, I'm doing all this. that's interesting. Huh. Okay. Well, that's a very clean way of doing it. I mean, I'd have to like read that over to understand exactly how it's working, but shoot. Not bad. Oh, dude, enough with the rotated array, brother. I want to go to bed. I don't want to do this anymore. I'm tired. I want to go to bed. I'm so tired. Yay! More rotated arrays. Honestly, binary search, an algorithm I used to be quite fond of. Now I kind of just don't really like it. You know, I'm tired of doing a binary search. I feel like it's just not fun. It was interesting at its practical core, but whenever you start getting into these kind of problems, it just feels Cocoa Eating Bananas that one made sense. That one was cool. These ones, you know, like a true person would just sort it. You know, we would just have it sorted. Like, we wouldn't be doing this silly rotated array. Like, I don't know. Maybe I'm wrong. Maybe this has, you know, implications like in GPU processing and whatnot. Trying to find the inflection points. Yeah, that's totally true. That could be definitely a thing. But man, is it a pain to work with. So if there's an enter nums ascending order. Oh, it could also just not exist. You son of a gun, man. Oh my goodness. I hate this so much. Of course. I mean, why not? Right? Why not? I mean, it's funny whenever we do stuff like that. It's quite hilarious. So why not? Why not? Why not? Why not? So I'm basically I'm thinking we're just gonna kind of do a check. A left, middle, right check. So. Actually, this is much easier. Sorry, I was just laying back for a second. Yeah. Whatever, just start programming. I'm overthinking some stuff right now. If target is greater than or equal to nums of left pointer and less, and target is less than nums of middle pointer, then we need to move left. We need to move left. So that would require a right of pointer equaling middle pointer minus 1. Else, if target is less than or equal to num of right pointer and target is greater than nums of middle pointer, then we need to move right. So left pointer is going to equal middle pointer plus 1, else target is equal to middle. Else return middle pointer. And yup, I believe that's misspell index out of range. Oof, yeah, I can imagine. Okay. Oh, you know what? How about... Yeah, how about... Ah! Oh. Stop it. No! -1. I mean, how are we breaking on this one? Are we just breaking on everything right now? Okay. We are literally just breaking on everything. Okay. Understood. Copy. Capiche. Why? Why are we doing that? We should not do that. Okay? That is not optimal. Please, for the love of God. Nums of left pointer. Gives up. It kapoops. Ah, right. Right. We're not thinking right now. Because there could be some inflection points. Damn it, Sterling. Why aren't you thinking right now, brother? Come on, man. Low-key, like, did I not just accidentally make regular binary search and then just call it a day? Idiot. Idiot, idiot. Uh, Crap. Do I need to test the edges? Oh, this is so silly. Well, I don't like doing this. I feel like this is too many cases. I never ever believe that we will use this many cases, but. I shouldn't have to worry about this on slowing anything down. I mean, so okay, that one passes, but it still fails here. Target is 4. I should be returning 3. 1, 3, 6. 1, 1, 2. I don't even know, man. This one is. It's funny. I was like, wow, this is gonna be easy, but here I am, get my butt kicked. Wait, no, that would make sense. Sorry, I'm tired. Okay, here's one way we could do this. If the target is smaller than middle, then I want to move towards the inflection point. If the target is greater than the middle, then I want to move away from the inflection point. Let's try it out. Nuns? Come on, bro. I don't know. I don't know what to tell you, man. 472. I'm looking for 5. See, crap. It's a problem. I don't need to go to the. How do I know where I need to go? Your target is. Yeah, I don't know. I give up. I'm tired. I don't even want to watch the video either. Oh, wait, I'm so close. Mother. I literally was just about to do that, but I was like, I don't think that was going to work. Ah, dude, I'm frying my brain right now. These lefts and rights are frying the hell out of my brain. I'm just throwing shit at the wall right now. I'm tired. I'll come back to this later. I don't want to do this anymore. Yeah, I'm waving the white flag and calling it a day because, Lord, am I beat and tired. I mean, it is 1 o'clock in the morning. My bedtime is way before this, and yeah, I'm done with that problem. Sorry, folks, I gave up. I'm not even gonna watch the video. Maybe I will tomorrow off camera, but I am tired and it is bedtime. Thank you for watching, and I'll see y'all tomorrow.